have just a few items to go over before we begin. Everyone in the audience will be muted. If you have any questions, please write them in the chat or question queue, and we'll be sure to answer your questions at the end. I think we're going to give people maybe 30 more seconds and we'll get started. All right, let's get started. Today's webinar overviews photogrammetry processing with DJI Terra. And to kick off this webinar is our enterprise survey and mapping consultant, Whitaker Gramley.
Hello, everybody. Thank you, Alex. Appreciate the intro. For those of you who don't know me yet, my name is Whitaker Gramley, and I'm a surveying and mapping specialist here at Multicopter Warehouse. Multicopter Warehouse, we're based here in Denver, Colorado, and we've been servicing multiple different verticals of the drone industry for over 10 years now. Those verticals include public safety, surveying and mapping, construction, mining, the list goes on and on. But my name is Whit. If you want to reach out to me directly, I've got my contact info here, but I'll be sure to put it up at the end as well. And today we're going to be talking about DJI Terra and using it for photogrammetry. Now, I know there's a lot of photogrammetry softwares out there, and DJI Terra is really popular when using it to process LiDAR data from DJI's L1 and L2. But I was kind of noticing there's not a whole lot of talk about using Terra for photogrammetry. And in the last year or so, they've added a lot of features which make it more comparable to other photogrammetry softwares you may be familiar with. So I thought it'd be a good time to do another webinar on DJI Terra. So today we're going to be going over specifically the photogrammetry tools in DJI Terra. We're not focusing on LiDAR or multispectral right now. So I'm going to be talking a little bit about that, going through the workflow for processing DJI Terra. And then we're going to be looking at some of the deliverables and leaving some time near the end for questions. So if you guys have questions throughout the presentation today, please put them in the chat box or the questions box, and Alex will read through them at the end. Now, without further ado, let's go. So this is DJI Terra. This is where I've got all of my missions that I've processed or begun to process over here on the left. And to start a photogrammetry processing job, we're just going to click New Mission. And then a visible light project is what we're going to be working on. Like I said, we're not going to be focusing on multispectral or LiDAR today. So we'll click on Visible Light, and we'll give this the name. Now this here is our main window where we'll be working with our data and doing most of our work. So let's go ahead and import a folder from one of the missions that I flew recently. Now when you fly a mission on your drone, it's actually going to, I can't talk and find it at the same time. It's actually going to put all of your photographs, all the files you need into one folder right here. So all I have to do is select the folder and bring it in. Here we can see the flight path that my drone took while I was flying the mission. And what we're going to want to do is import some ground control points to tie all of these photos to each other and to a coordinate system more accurately. Now I flew this mission at about 150 feet with RTK, which will increase our accuracy quite a lot, but I'm looking to get a little bit more accuracy by tying in some ground control points, and that way I can double check my work as well. The ground control page takes a second to load, but here we go. We're going to import our GCP file right up here at the top right. And for the sake of simplicity today, I just have one ground control point, but I would like to show you guys the file so you get an understanding of what we're actually looking at here. Alex, let me know if you guys cannot see this Excel spreadsheet. But basically, we've got our columns, we've got a point number, northing, easting, ellipsoid height, and then I've got my coordinate system that my control point is in, and then down here we have our actual points. So that's what we're going to be importing here. And what we need to do is take a look at that first row of your spreadsheet. If it just starts with your northing, easting, and elevations, then we don't have to worry about this first section here. But because I have one row dedicated to the names of my columns here, I'm going to skip the first row from the top. So we only have the row with our points in them. So first thing we'll want to do is tell the software what each one of these columns represents. So this is the name of the point, this is the northing, this is the easting, and this is our altitude. Now that I've used my cheat sheet row here, I can just click to skip the first row, and we've got all of our names still tagged here. And then what we're going to want to do is choose our coordinate system. So when flying a DJI drone and when using the base station, the DRTK2, everything is collected in WGS84 format. That's no problem though. We can change this to whatever we want when we go into process. So I'm going to want to make sure that I select the coordinate system that I used for these ground control points. So I've got it already up here. I used NAD83 2011, but if it wasn't right there, I've used this recently, so it was right up at the top. We can actually search by the ESP or EPSG codes. I'm going to select that, and I'm going to leave my default or my geoid setting at default, and I'm going to go ahead and import this control point. Give it a second to crunch the numbers there. Now you see we have a little pin here around the camera shots where we took pictures from the drone. And as you can see, our control point is actually above the pictures right now. And that is exactly why we're doing this, is because we're getting pretty accurate with the drone, but we know this point is actually on the ground. And so we need to tie this ground control point to its actual coordinates in the photos. So we're going to display all the photos. And what we're going to want to do is look through these photos and tell it where the center of our checkpoint is. So if you see all down here, we have all of the photos. We're just going to click on the first one. Just going to look for photos with my control point. Here we go. So there's my control point right there. We're going to tell it this is the center of my control point. But first we need to arrow triangulate all of our photos in the ground control point. So we're going to hit that real quick and let it triangulate all of these pictures first. The nice thing about doing this is also once we set up our arrow triangulation and click on a couple control points, the software itself is going to try to tag the rest of those control points automatically. And that will go by each individual point. So if I had 5 control points and I tag a couple of the first one, it'll do its best to tag the rest of those control points, and then I can move to number 2, tag a couple of those pictures, and then it'll automatically select the center or do its best. So I always recommend checking a lot of different ground control points, at least like 4 or 5 of them before you really trust the computer to select the center. Should wrap up. Usually the second half goes a little faster than the first half. While we wait, Alex, do we have a second for a question if we've got any?
Let's see. I do have one question. Can you
Oh,
use PPK processing in DJI Terra?
yes, yes, you can. Today I'm focusing on doing a flight with RTK and using the ground control points, but it might be something that would be good to do a webinar on the future. But basically you could export all of your pictures and do PPK on those the geotags and then re-import the corrected data to your photos in Terra. Thank you, Alex. So now you can see we've done the arrow triangulation, and what this has done is basically picked out several points. We've got a kind of a sparse point cloud here right now. And these are kind of like our tie points where it's going to use these to continue processing the pictures once we've selected all of our options. But for now, what we need to do is calibrate to our GCP. So I'm going to zoom in on my picture. I've already done this one. This here is the center. Now you see it's already, you see how this first picture on the bottom left says manual. I have manually clicked the center of this point. The rest of these say auto though. So it's done its best to pick out the center on all these other pictures. I'm going to just go through and correct it on a couple of these to make sure that we really narrow down on the center. 3, 4, that one's pretty good already. 5. And see, once we've done a couple, it's pretty good at picking out where the center is. And you don't have to worry after you've done about 3 or 4. So now we've selected our center here. And if we had multiple ground control points, I would just select GCP number 2 and do the same thing. But what we can do now is go ahead and close this out, the GCP management. And we're going to go through, today we're going to process an orthomosaic, a 2-dimensional map. And then we're also going to process a 3-dimensional point cloud. And we're going to go ahead and do a 3-dimensional model of this site as well. So we've got our GCPs put in, we've selected the center point. Now we're going to turn on the switch for the 2D map. We've got resolution. You can adjust this if you don't care as much about getting the most resolution out of your data and you want to process a lot faster. We can take this down to low. I'm going to leave it on high for now. You can always remove data later, but if you process it into a low resolution, you can't really add more resolution down the road. For the scene, we've got options for field. This would be great for agricultural purposes. It's like more monotonous terrain is going to be a little trickier for the mapping scene to work with. So if you're doing like a soybean field or an empty cloud crop field, I would use the field option. And then they also have an option for fruit farms like orchards and stuff like that. Since this is mostly an urban scene though, I'm just going to stick with the default mapping scenario. And then DJI Terra offers multiple computation options. The one most people use, or the one I use mostly, is standalone computation. This will process everything natively on your local hardware. Now, if you did get a cluster version, cluster license of DJI Terra, you could install it on multiple computers and they would run in parallel to process your data faster. You would still have one main computer where you're doing all this work setting it up, but then once you click to start the process, it'll kind of divvy it up amongst multiple workstations. And then under advanced, we are going to want to make sure that we're using the same coordinate systems that we want to output the data as the coordinate system we were putting the GCPs in. So I've already got it set up, NAT 83 2011. We're going to leave the geoid settings at default again. Now this haze reduction, if I had flown this on kind of a hazy day or a foggy day, I might turn this setting on to reduce some of that hazy coloring in my point cloud in my data. But I flew this on a pretty clear day, so I'm going to leave it alone for now. Something that's cool about Terra that I always appreciate in softwares is that near most of the options here, you have little icons you could hover over that will explain to you what each one of these options does. So if you're ever in a tight spot and you're not sure if you wanted to use one of these options or not, you just go ahead and hover over it. It's pretty good about explaining itself. So that's it for the 2-dimensional map. We haven't processed it yet, but we've set everything up. So we'll close this. We are leaving it turned on though. And we'll turn on the 3D model here. Again, same thing with the resolution. If we want to process this faster, we can turn it down, but you can't increase your resolution after you've already processed. So I'm going to leave it turned on to high. Again, standalone computation is what I'm going to use. I don't have cluster, not yet anyways. And then our output formats, by default, it's only going to make a three-dimensional model. But I know a lot of people are very used to working with point clouds. So I'm going to turn on a point cloud as well. So we're going to create a 3D model of this area, as well as a point cloud of this area. I like the LAS format, so I'm going to select to create an LAS format point cloud here as well. Here are all the options for creating a model. We have a lot of different file types, B3DM, OSGB, PLY, etc. And then for point clouds, same thing. We've got a lot of different options. I'm going to use the LAS version though. And then if we go under advanced, again here, this is where we will want to make sure that we set the coordinate system to be the same as our ground control point coordinate system. And photogrammetry, if you haven't ever flown over a pond or a lake with a drone before, has a kind of a hard time with ponds and lakes. So if you wanted to refine the water surface, it'll actually identify where the water is and try to reduce the pitting or the peaking of the lakes that you see. And then DJI actually released recently software called DJI Modify. It allows you to kind of clean up your models in point clouds and work a little bit more in depth with the data than you can in DJI Terra. And I believe it's still in a beta version. So if anybody wants to try it out, you can test it out for free. But you need to set it up in Terra to work with DJI Modify first. So just if you want to work with Modify, flip this switch on here real quick. And then all we need to do, once we've selected all of our three-dimensional model options, is we're just going to go down here and hit Start Reconstruction. Now, Alex, we'll probably have time for a couple questions here. I'm not going to run the whole process. I'm going to cut it off here early. I've already processed this yesterday, as a matter of fact. So we'll go ahead and look over the results. But something I noticed interesting about DJI Terra is that the processing time is actually a lot quicker than some other photogrammetry softwares that I've used before. I'm not exactly sure how they're doing it. It must have something to do with the algorithms and some optimizations that they've done under the hood, but I've always been very impressed with how quickly we're able to process things. So our two-dimensional ortho is actually 50% done already. And once it goes through that point, then we will be, it'll start automatically on the three-dimensional processing. Alex, did we get any more questions in the meantime?
Yeah, so we got a couple questions about 10 minutes ago. One person is asking, what hardware are you using to run the application? I'm assuming they're asking about the laptop.
Yeah, so I have, my boss bought me an MSI Intel Core i9 gaming laptop. It's important to have, if I remember correctly, the system requirements require a minimum of 32 gigabytes of RAM and a pretty good RTX capable graphics card. So if you get a gaming laptop with 30 gigabytes of RAM or a gaming desktop with 30 gigabytes of RAM, chances are you're going to be well within the system requirements. Of course, if you aren't super technically, technical in computer specs and stuff like that, you're welcome to call us here. I built a lot of my own computers, and our technician, Cody, has built a lot more than me. So it's something we can definitely help you out with. We'll hold the rest of the questions for the end, Alex. Thank you. But I'll go ahead and stop this process, and we'll go ahead and take a look at the data set. So this is what we've already seen before. This is our triangulation. This is our loose sparse point cloud that we generated at the beginning. And then if we select 2D map, here we can see our ortho mosaic that we've stitched together. Now, all these white dots, that's the path. Again, that's the path that the drone took for this mission. And we can turn that off just by hitting this button up at the top right, the little blue camera icon. There we go. Now we have a nice clean ortho mosaic of our site. And then if we go into the three-dimensional model section, this is the model, and this is the point cloud. We can adjust the size of the points if we want to, just so we can kind of get a better idea of how many points we've actually calculated here. We've got quite a few, very dense point cloud. But something that we can do with DJI Terra at this point, before we export all of our deliverables, we can actually do some volumetric calculations. So if you had a stockpile site, or you needed to figure out how much dirt to bring in to fill up a hole or something like that, you can actually just calculate it with this volumetric tool right here. The way I did that was basically we select the volumetric tool over here, and then all we do is drop pins around the 3D object that we want to measure. And on the last one, double click. My apologies, it's freezing up a little bit on me here.
We had a question pop up with, do you have a second to answer it?
Yes, please.
Can you change the volumetric units to US standard?
Yes. So if we go into the settings over here, change our length units to feet and our area units to feet, I think this should change our volumetric units, but let us double check here. So well, I apologize. I can't remember the button to drop the last pin and calculate the volumetrics. Sorry about that. But if you do want to see that live, I'll figure it out, and just reach out to me. I'll show you. Anyways, another thing that I thought was very impressive with DJI Terra is not only can we process things significantly faster, but when you fly the mission with the right goals in mind, you can actually create some pretty impressive three-dimensional models. So this is a different flight that I did and processed in DJI Terra, but my goal here was to get as much detail out of the HVAC equipment on top of our roof. And so you can see I did a standard drone mission, cross-hatch, north-south, north-south, and then east-west, east-west on top of the building. And then I actually flew down really close to the building with my Mavic 3 Enterprise. And I did a point of interest mode flight around this HVAC setup. And what we found was not only is it processing things significantly faster than other photogrammetry softwares, but we're getting details that I was never able to get from other softwares. So we can almost read, some of the signage on this equipment. We can see each individual grid fin. We can see imperfections. We can see the granularity at the bottom on the roof here. And I just thought that was really cool. So you can create 3D twins really easily with this software and with something like a Mavic 3 Enterprise. Now I think we are starting to run low on time, so let's kick it off over to the questions. Let's wrap up the rest of our questions if we could. Just 1 second, Alex will be giving us the rest of the questions.
Thanks, Whit. So we had someone ask, what was the total compute time for this past your example?
For the second one, well, I can't ask them questions, can I? Anyways, for the first one, it probably took about 30 or 40 minutes for just the standard mapping mission. The second one, I did set it up the one with more pictures than the orbits, I set that up to process overnight. So I didn't see exactly when it stopped, but I would have to guess it took maybe an hour, maybe an hour and a half to process all of that.
Perfect. And then someone is asking in the Excel spreadsheet you presented earlier, was that created by the user?
That is a good question. So for this mission, for those ground control points that I used, I actually used arrow points from this company called Propeller. The Propeller arrow points are my favorite way to put in my ground control points just because all you have to do is throw them out on the ground. They have solar panels in them, and then they collect data all by themselves. So they gather the data, and then when they get within range of your Wi-Fi, they will automatically upload those points. And then using your account, the software that Propeller has created, you can PPK the points on those arrow points and then export it into a CSV. So by project, I could throw out as many arrow points as I wanted to, tell it what coordinate system I want my points in, and then after maybe 30 minutes to an hour of processing, it'll send me an email that says it's ready, and I can just download that file. So that file was created by Propeller arrow points.
Awesome. Do have a question here. Do you need an internet connection to process data in Terra?
Most of the time, yes. So in order to activate Terra, in order to use Terra, you do need to be connected to the internet. However, DJI understands that is not something that's feasible for everybody in all circumstances. And so there is also an offline license version that you can get instead.
And then I think this is the last question. Can the ZenMuse L1 and L2 raw data be processed without an RTK connection?
Yes, yes, it's significantly trickier to process your L1 and L2 data in DJI Terra without the RTK connection, but you can PPK process your data. So RTK is definitely still going to help, and it's recommended because it's not just using the RTK to correct the LiDAR data, but it's using the RTK to guide the drone and keep it as accurately as possible on that flight plan. And so when you're dealing with overlaps and you want to make sure you're not missing any sections between passes, the RTK will help ensure that the drone is following the exact course that you had planned. That being said, you can PPK the data after the fact as well.
Sounds great. I think that might be it, unless anyone has any last minute questions. I'll give them a couple
All
more
right,
minutes. We do have 1 more minute of this webinar time frame.
sure. Yeah, we'll give 1 more minute to ask any questions. Everybody who would like to reach out if you have further questions or would like to talk more in depth about this stuff, feel free to reach me at the phone numbers below. I should put my email address on there as well, but it's wgramley@multicopterwarehouse.com.
Perfect. Yes, someone did ask if we're going to post this webinar. Yes, we are going to have this webinar posted on our new website as well as our YouTube channel. We have a folder on our YouTube channel for all of our webinars that have been recorded in the past. But it looks like
Yes.
that's all the questions for now, Whit.
Cool. Yeah, everybody should check out our new website. Alex spent the last several months working on that, and we just launched it a few weeks ago. Thank you, Alex. We're very happy with it. So everybody feel free to check it out. You can reach us on our website as well as look at some of our offerings.
Perfect. I think that wraps it up. Thank you everyone for attending.
Yep. Thank you, everybody. We'll see you next time.